Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat unusual boundary between our daily reality and the somewhat strange world of quantum mechanics, but specifically an experiment that actually shifted this boundary just a little bit, allowing certain things and certain objects that we take for granted to basically enter this quantum realm. And by itself, this is kind of important because for many decades, this idea of quantum reality, or the famous Schrödinger's cat, or the cat inside a box that's both dead and alive and whose condition is unknown until you open the box, or just to rephrase this, basically these large objects existing in two separate states at the same time, was believed to be maybe a thought experiment, just to show us how strange these subatomic particles and a lot of tiny particles usually behave. But as of early 2026, because of several major experiments and because of several advances, this is no longer just a thought experiment anymore. As a matter of fact, as you can see from this graph, in the last few decades, and especially as of early 2026, researchers were able to push the limits of what can acquire this quantum state by basically moving from a single atom or from some kind of a state such as the Bose-Einstein condensate to something that involves massive clusters of matter and even mechanical drums that you can actually see with a microscope. And so in this video we're going to discuss the recent experiment and some of the recent achievements, but specifically discuss how the scientists in this study managed to make a tiny rock behave like a wave. And that's basically one of the biggest breakthroughs in quantum mechanics in 2026. It's based on this study by Sebastian Pedalino and the team you see in this list. The researchers from University of Vienna and University of Duisburg-Essen. And so in this experiment, researchers were officially able to smash the previous record by allowing a macroscopic object, or a large object, to acquire a quantum state. Although for our eyes, the object is still kind of microscopic, but when it comes to quantum mechanics, this is the largest object so far. And it kind of resembles this. It's this sodium nanocluster that's approximately 10 nanometers across. And as you can see, for a comparison, here we have a typical antibody and a tobacco virus. And so yeah, it is small, but definitely much bigger than anything previously, and something that in theory can be visualized with the microscope. And here the sodium nanocluster, which is basically a microscopic clump of metal, in this case containing 7,000 individual atoms, has a mass of approximately 170,000 atomic mass units, which is a mass of a typical large protein inside our cells. But the point here was to send these relatively large objects, or these clusters, through what's known as an interferometer, a device that uses ultraviolet lasers to create gratings of light. Here these lasers act as a kind of a spatial filter, confining the particles to specific nodes or narrow paths. And according to the uncertainty principle, by squeezing the position of these unusual particles, researchers created just the right uncertainty in their momentum. But then came the important part, the so-called quantum shift. Here the clusters were then hit with a second UV laser, which instead of just blocking the particles, also gave them a kind of a phase shift. And this allowed these particles to delocalize, basically making them enter a kind of a superposition state, which allowed them to follow multiple paths. And at this stage, each of these larger particles was effectively in two places at the same time. Here they were separated by a distance of 133 nanometers, roughly around 10 times its own size. With the third important step obviously being measurements. Here the third laser was then used to resolve the results and was used to produce interference fringes, or the telltale stripes that only appear when waves overlap. This is basically something we detect in all quantum experiments. And the fact that they saw these fringes definitively proves that sodium did not travel like a classical cannonball, but instead traveled like a wave, occupying multiple paths simultaneously. And so here the study achieved the largest macroscopicity when it comes to quantum physics. In this case, macroscopicity is measured with the value mu, and it relies on the measurement of experiments trying to test the limits of quantum theory. Here this value was 15.5, which was much larger than anything before. This also marks the first time ever that metal clusters, or the new class of materials for such experiments, have been used to demonstrate the matter-wave interference. Normally metals are actually kind of difficult to work with, because they tend to interact with their environments very easily. Or actually they tend to destroy these quantum states, or basically become decoherent pretty quickly. But this is definitely a major achievement. Because here the study addresses a fundamental question in physics. So where exactly does the quantum world end and the classical world begin? And well, the thing is, there seems to be no answer right now. By showing that these massive particles can become quantum, researchers confirm that there is currently no observed mass limit. As a matter of fact, if once again you look at this graph here, you can kind of see a progression line that just keeps getting higher and higher and higher, which of course paves the way for even more ambitious experiments or possibly new physical models that have to try to explain where this quantum effect breaks down or whether there is a limit at all. As a matter of fact, in the last few years we've discussed some really intriguing propositions in regards to quantum effects, such as one interesting proposition that the microtubules inside our brain might also experience a lot of quantum effects and thus create the idea of consciousness. You can learn about this somewhat controversial topic in one of the videos in the description, but this is of course one of many reasons why this experiment is so exciting. And you can actually see some of the other experiments we discussed previously in this list as well. For example, the green square you see here, this is another recent study involving the collective quantum motion of 6 microscopic mechanical oscillators, or basically 6 tiny drums. And in this case, by cooling down these drums to very low energies, researchers allowed them to achieve their ground state, which then created a somewhat bizarre effect. Instead of each of the drums moving independently, all 6 drums actually entered a unified collective state, vibrating at the same time as a single quantum entity. With additional experiments in 2025, using slightly different drum heads, and something that was even larger. And surprisingly here, these drums were even able to maintain their quantum connection, even in the presence of environmental noise. Normally this would destroy these quantum states, but in this case it didn't. And so here these drums were able to maintain their quantum connection indefinitely. It was reported in the study you can find in the description, and these drums essentially resembled something like this. And because of these experiments, we can now actually start tackling other questions involving questions in astronomy and biology that sometimes relied on these quantum effects or macroscopic quantum effects for a potential explanation. For example, in astrophysics, some theories involving gravity and dark matter actually use quantum mechanics and quantum states and the collapse of these states to explain certain effects we observe around us. For example, the idea behind dark matter is sometimes explained with the principle known as axions. And here these superlight axions would actually be these quantum waves oscillating across the universe. Now we've discussed one of these explanations in some of the videos in the description, but the point here is that maybe these quantum effects don't really have any size or mass limit and can actually occur on extremely large scales. But as I mentioned for biology, there is another really intriguing concept. The concept that was explored in one of the recent studies, and that once again we discussed in the video in the description. The idea referred to as the orchestrated objective reduction. This was proposed by Roger Penrose and Stuart Hameroff a few years back. And well, the point is that there might be some evidence that human brain, specifically living human brain, creates large-scale quantum entanglement inside tiny structures referred to as microtubules, the tiny long structures used by cells for a lot of different functions, everything from support to transportations to some of the most vital cell processes, like for example cell reproduction. And well, based on some of the studies in the last few years, there could be some evidence for this quantum consciousness, or basically the idea that something quantum is actually going on inside our brains, but exactly what, nobody knows just yet. And if correct, this would actually mean that even our brains seem to act as these relatively large microscopic quantum states, something that was previously believed to be kind of impossible. But a lot of this other stuff is of course somewhat hypothetical for now, and the only thing that's certain is that researchers are just getting better and better at making larger and larger objects into Schrödinger's cats. And based on this graph again, we can only assume that the next object might be even much bigger. And the conclusion from all of this is that this quantum weirdness does not seem to have a strict size limit and seems to be all about the proper environment and the proper type of isolation, which one day might help us answer some questions about what exactly is this quantum world, and I guess more importantly, if we're all actually just living in some kind of a massive complex quantum state. But we'll discuss this more in some of the future videos, because I don't really want to speculate yet. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.